Hello, mathematicians, and welcome to the part 2 video on finding determinants of matrices. So an ACT topic for sure. I'd like to see you get that when you take that test. So if you watched the previous video, and I hope you did, we pointed this out, but I'm going to point it out again. You will notice that the symbols are not brackets. They don't have the little hooks on the ends. It almost looks like an absolute value, but it's not. It stands for determinant. So if you see that on an ACT test, they're talking about this procedure. So if you didn't watch the first video, let me point something out to you over here in this blue box. It says combine, which implies to add, right? Add or subtract. Combine all the right-facing diagonals. So here's what we mean by right-facing diagonals. If I connect that guy to that guy, that's a diagonal, and I'm going to times those out. But I also want to do a diagonal of the 6 and 11, but diagonal always has 3 when you're talking about a 3 by 3 matrix. It would be 4 if there's a 4 by matrix, and so on. So if you look at that previous example up there in 3, what we did was we rewrote the first column right next door, and we rewrote the second column right next door. And now you can kind of complete those diagonals. So here's another diagonal for those 3 guys. So I'm going to move this up a little bit, give myself lots of room, because this does take up lots of room. But it is a calculator issue for the most part. So I've got a 10 times a negative 5 times a negative 9. So the blue box said to total up the diagonals, and that means by multiplying the diagonals. So the second diagonal goes from the 6 to the 11. And when we rewrote that 1, it makes it easy to find that third number. And then the third facing diagonal, right facing diagonal, goes from the 5 to the 3 to the 0. And that would be our right facing diagonals. So I'll go back and add those up here momentarily. All right, left facing diagonals. Going to the left. 5 times negative 5 times 1 plus 10 times 11 times 0. You might be thinking to yourself, well, if I times it by 0, that's going to end up being 0, and you're not wrong. You could shortcut that if you wanted to. And there's the other left-facing diagonal. So 6 and 3 and negative 9. So I'm going to total the bottom up first here only because I have the purple marker. So let's see, I've got a negative 25 times 1, which should be negative 25. And we already pointed out that middle one is convenient when you become 0. That's a little easier. And the last one, 6 times 3 times negative 9. I'm going to need a calculator for that, folks. So 6 times 3 times negative 9 would be a negative 162. So a grand total of negative 187, right? Yep. Okay, the green one, the right diagonals. So let's total those up. Well, let's see. 10 times 5 is 50 times 9 is 450, and a negative times negative would give me positive. Plus 6 times 11 is 66 times 1. Plus anything times 0 would be 0. So it'd be a total of 516. And then I'm supposed to subtract the 2. So the right diagonal total, which was 516, minus the left diagonal total, which was negative 187. 2 minuses makes plus. Let's use a calculator for that so I don't screw it up. So 516 and 187 is a total of 703. Okay, don't think the numbers have to be big for these. It could be anything. You're talking about negatives and positives, so negatives obviously make it go down, and positives make it go up. All right, there is a word problem to check out. This is why I like matrices. They're kind of cool. Notice Tuscaroras County. So if you can imagine that we drew a grid, a coordinate grid, right through Port Washington, because Port Washington is the center of humanity, if you didn't know that. We could make coordinates out of those. So if I was to use Port Washington and Denison, and I forget what the third one is, I'm going to have to cheat. Roswell. Where the heck's Roswell on this map? Oh, good Lord, I can't find Roswell. Oh, here it is. So we could make a triangle out of that. And we could use a matrix to find area. So that's what this is doing down here. So I am going to make a matrix and find the determinant. Believe it or not, the determinant of the matrix will help you find the area of an object. So I've got 0, 0 for my first set of coordinates. That's where we put Denison. 12, 3. Now, if you looked at the old-fashioned maps, kind of you fold out, they actually have more or less a coordinate grid on them. So believe it or not, it would be possible to do that with a map. 13, 9. Now, if you're paying attention on the first video, you would know that it has to be an equal number of rows and columns. So I can't do a 3 by 2. So here's what's another thing that's cool about matrices. If I were to just put 1s there, what happens if you times something by a 1? It doesn't change the value. So you can always add 1s to a determinant matrix to help you out. So if you recall, the area of a triangle always had 1/2. So that's how we're going to do it with a matrix as well. So to find the area of a matrix for a triangular matrix, like the one we just drew, it's 1/2 times the determinant of the matrix. So wouldn't worry so much about the word problem. Just remember how you set up a determinant. And the determinant is to do this. We want to repeat the first 2 columns. And then we want to do our diagonals. Of course, doing the diagonals means to multiply. So I'm going to cheat a little bit. I'm not going to write all this out. 0 times 3 times 1. So I'm going to put R for right diagonals. And 0 times anything will be 0, right? Okay, but the formula or the system or the procedure is to add up the right diagonals. Well, 0 times 1 times 13 will also be 0. So conveniently, this has been pretty easy to figure so far. 1 times 12 is 12. 12 times 9 is 108. Feel free to use a calculator. So the total for my right-facing diagonals is 108. Okay, let's get the left-facing diagonals. Assuming I can get this thing to work. Let's go with orange. A little trouble there. All right, left-facing diagonals. That's the only spot I can get all the way across, right? So 1 times 3 times 13 for the left diagonals would be a 39 plus 0 times anything would be 0 plus 0 times anything will be 0. 39. So how do you find a determinant? You get your total of your right diagonals, which we got. You get your total of your left diagonals. And if you watch the first video, if you're doing a 2 by 2 matrix, it's 100 times easier than this. But then you subtract them. So 108 minus 40 would be 68. But I didn't take away 40. I only took away that. So it would be 69. So my determinant, I'm going to put a D for determinant, is 69. So if all we were asking you to do here was find the determinant of that matrix that we'd set up, the answer would be 69. However, we were trying to find the area of the land involved in that triangular figure. So just like the normal formula for area of a triangle, you take half of the base times the height. So for all intent and purposes, that's what your determinant was, the base times the height. So if we take half of 69, you get 34.5. And we were talking about miles in this problem. If you're talking about area, you're talking about square miles. So if you were king of central Tuscarawas County, as the word problem states, you would own 34.5 square miles of property. So matrices do have some applications on the ACT test. They're probably going to give you something straightforward, like just find the determinant. But again, if you know the procedure and you have a calculator, that's pretty darn easy. But please, this symbol, non-absolute value, stands for determinants. Thanks for watching part 2, guys.